Hello everyone, welcome to this new stream that is an odd day. First time I stream on Friday, I think. It should be. Luckily is here once again and we are changing things. We won't be working on what I was thinking I would be working today. We will be working on something different, as you may have gathered by the title of the stream. I'm going to work on Kubernetes, and I will be shelving currently the OpenWRT virtual machine. I did a tiny bit of research, and on top of that, I have a different situation now. So if you may recall, I don't even remember if I actually said this, but my connectivity is it has been fairly good since before I started streaming. I have fiber to the home, so I have the actual fiber inside my house. With the previous provider, that went directly into my router. So I actually took some time to search for a replacement because the router from my provider was awful, to be honest. I couldn't change certain configurations, and other configurations, to change them I would need to basically factory reset the router, no, disconnect it from the fiber first. Yeah, I think so. How do I connect to it then? Yes, directly from internet, I guess. Factory reset it, and then I would see the maybe I didn't try it actually. Then I would see the possibility to change certain configurations, but only temporarily. As soon as the fiber link will be connected, the fiber cable will be connected, the UI would disappear from the settings, which is mindless. I didn't actually try, so maybe even that is not exactly true, but I don't have that issue anymore. I have a new provider that gave me a new router, but it's not the new router. The things that made the factor that made me change ideas, it is actually the fact that the fiber cable is not directly connected to the router, because I did search for a replacement and it was mindless how expensive it was. Definitely not in any budget for myself. So I decided to, okay, let's not do that, but I need anyways to look into some better ways to manage my connectivity. So OpenWRT inside the VM was a possibility. I knew that the, I don't want to even say the quality, but there would be risks with having OpenWRT inside a virtual machine. I decided to try it anyways, and it works. At the same time, I don't have the issue I had before anymore, because now I can change a router with anything I want, basically. Even a cheap, whatever, used stuff that is old, so that I get hacked in 0 time, which is not something I will do, but that is a possibility now. So I will likely look into a physical router to put where to put OpenWRT. but I will take some time to do that. In the meantime, I can actually learn a little bit on how to configure OpenWRT with the virtual machine I created. Everything that is related to OpenWRT will be moved offline. And indeed, I have already started to create the new notes for today with the new long-term plans. Because the previous long-term plans involved an Ansible playbook that we saw last stream is not feasible. Not exactly correct to say it like that, but I would need to install Python on the OpenWRT virtual machine manually before I can use Ansible with it. I'm not sure it makes sense, so I won't be even trying that. Last time I said that I would create a shell script, given that OpenWRT default shell is ash or ash. What was it? Yeah, Olmquist shell, I guess it's pronounced. So that was the idea, but again, do I really need it? Given the new ideas, the new plans? Maybe not. Maybe I will need it anyways. Maybe I will work on it anyways just for fun. When I have time to work for fun. Let me see. Oh, Jesus. Nope. That is not what I wanted to paste. Let me see. Here it is. Shouldn't do anything wrong to me. Check plans. Let's start with Kube. And indeed, that is what I plan to do today. I plan to start with Kubernetes. If you have watched a few of my streams, you may say, what? If you watched them all, thank you, first of all. But on top of that, the first idea was to create the underlying infrastructure for a Kubernetes cluster. And this is something that I finished, technically speaking, last stream. Because now, if I go in here, I have cleaned up a little bit, and we have the router that will stay there for the time being, because I need to do some tests with it. But then I have all my various VMs that I created last time, and I can recreate as needed really quickly. Same with the templates. That is because I created the OpenTOF definitions to interact with Proxmox and create all the underlying infrastructure as needed in a matter of minutes. So if I destroy stuff, which is likely to happen when I work on Kube, because I don't have that much knowledge about Kube, I will be learning things, I would say similarly to what I've done so far. Well, the idea will be that in case of need, everything can be destroyed. The evolution of this kind of underlying infrastructure could be to look into MGMT, as I mentioned last time. I didn't have time to look into it, so I don't know much yet, but if what I understood from what a friend of mine told me, it's almost like dark magic, and I can create everything with it up until this point and beyond that, actually. So that may be interesting. but for the time being I want to start to look into a Kubernetes cluster. That means looking into the Kubernetes documentation, and that is what I will start to do right now. And there we go. Documentation. Perfect available documentation versions. And that is why I want to do this. Kubernetes is an open source container orchestration engine for automating deployment, scaling, and management of containerized applications. The open source project is hosted by the Cloud Native Computing Foundation, since CF. Okay, so far so good. I think that all of the services that I care about are containerized applications or come in containerized applications. Therefore, they fit perfectly in a Kubernetes cluster. And the nice thing about a Kubernetes cluster, as far as I understood, is that it is possible to configure it as a self-healing infrastructure. Therefore, whenever, given I describe a state in which my cluster should be, whenever I destroy something, it will arise from the dead, basically, by itself, without any need for me to do anything. So if there is something broken, it should fix itself. It depends on how it's broken, I guess, but we will need to learn things. So I did study a little bit of concepts before, a few months ago, because I did start creating something with K8s, which is what I plan to actually use, because I like to, I guess, make my life miserable. But anyways, I want to learn stuff about Kubernetes, so Minikube or K0s I don't think would fit my needs. Oh, so we have probably what I need in here, because that is what I want to do. Learning environment, production environment, install the Kube ADM setup tool, metrics, logs, traces, securing a cluster, this will be fun, Kube ADM command reference. Learn how to use Kubernetes, kubectl quick reference, install kubectl, configure access to the cluster, access to clusters, okay, use the web UI dashboard, configure a pod to use a config map. This sounds like a really specific thing, but it's okay. Getting help, yeah, I would need help. Thankfully, I do have a little bit of knowledge, and I do have a little bit of experience with a cluster of, well, maybe a couple of clusters actually, that my friends work on. Anyways, definitely not Minikube. Work through the basics, stateful example. So examples may be useful, but we will see. Anyways, if I go into learning environment, what? If you're learning Kubernetes, use the tools supported by the Kubernetes community or tools in the ecosystem to set up a Kubernetes cluster on a local machine. Interesting. What is this learning environment? Kubernetes in Docker, Minikube. No, I tried this, and then when I tried to move to K8s, it wasn't exactly like that, actually. So I will try directly Kubernetes, K8s, or the local option, yeah, whatever. Use online playgrounds, practicing with production-like cluster. If you want to practice setting up a more production-like cluster, you can use Kube ADM. Setting up a cluster with Kube ADM is an advanced task that requires multiple machines, physical or virtual, and careful configuration. For learning about production, I see production. Thank you. Thank you. That's what I want. Create a production quality Kubernetes cluster. See, I don't see why I should play with small toys. If I want to learn how to, let's say, build the engine of a car, why would I try to do it with Lego? Maybe I can try it with a small engine from a scooter, I guess. Or maybe if I care about an electric engine, again, an electric scooter. Why would I go with Lego? I have the documentation and I have everything else ready. So, a production quality Kubernetes cluster requires planning and preparation. Okay. If your Kubernetes cluster is to run critical workloads, it must be configured to be resilient. And that is one of the words that I like the most. My infrastructure should be resilient. This page explains steps you can take to set up a production-ready cluster or to promote an existing cluster for production use. In my case, is a setup of a new cluster. If you're already familiar with the production setup and want the links, skip to what's next. Nope, because I did most likely read already everything I am reading, but it was such a long time ago that I don't practice a lot my Kubernetes knowledge, so I don't really remember. Production consideration. Typically, a production Kubernetes cluster environment has more requirements than a personal learning development or test environment Kubernetes. Okay, a production environment may require secure access by many users. Not the case for the time being. Consistent availability, definitely yes, and the resources to adapt to changing demands. Let's hope I have those to a degree. As you decide where you want your production Kubernetes environment to live, on premises or in a cloud, and the amount of management you want to take on or hand to others, consider how your requirements for a Kubernetes cluster are influenced by the following issues. Availability. A single machine Kubernetes learning environment has a single point of failure. Creating a highly available cluster means considering 1. Separating the control plane from the worker nodes. 2. Replicating the control plane's components on multiple nodes. 3. Load balancing traffic to the cluster's API server. And 4. Having enough worker nodes available or able to quickly become available as changing workloads warrant it. So, what is not exactly perfect in my case, at least currently. I have my Proxmox node, that is a one node, and inside I have both control plane and worker nodes. That sounds like it's bad. Load balancing the traffic to the cluster's API server will need to be configured. I don't know how currently, but we will learn. Enough worker nodes available. That is another thing that I will need to work on. Thankfully, I have ideas for that, because I have, technically speaking, two other computers, one of which, both of which, one of them is running the Joplin server as well as some other services. The other node, the other computer, is also running some other services, but at the same time, all of those can be, there is a term that would fit perfectly, but I cannot remember it, but basically I can put all the services in one of those computers, everything will work fairly well, like that, and then I can most likely install Proxmox on the free computer, I guess, and have maybe a clusterized Proxmox virtualization environment, so that I can move one of the control planes to the other physical node, and eventually when I move the services on the last computer in the Kubernetes cluster, I can do the same steps. Install Proxmox in the third physical node, third computer, move one of the control planes in the third node, so I have three nodes, one of which with one of the control planes, and all of which will have some worker node. Obviously, we will see. It will take time, but not that much time, because maybe not today, given I'm learning, relearning from scratch many things, and I am also talking a lot. I'm in the mood to talk a lot tonight. But in a few streams I will have at least a basic cluster where I can start to deploy some service. Maybe something easy that has an Helm chart, maybe, or I don't know. We will start from basic, really basic things. And we will see how it goes. Anyways, we were saying, following issues: scale. If you expect your production environment, production Kubernetes environment, to receive a stable amount of demand, you might be able to set up for the capacity you need and be done. However, if you expect demand to grow over time or change dramatically based on things like season or special events, you need to plan how to scale to relieve increased pressures from more requests to the control plane and worker nodes, or scale down to reduce unused resources. That won't be much of an issue, because let me think. I don't think that this cluster, at least this cluster, will serve many people. This is personal, let's say, it's the personal cluster. Whereas I may set up another cluster for other people, maybe, and give some services to friends, and strangers maybe too. We will see. Security and access management. This is important and I have a little knowledge about this. You have full admin privileges on your own Kubernetes learning cluster, but shared clusters with important workloads and more than one or two users require a more refined approach to who and what can access cluster resources. You can use role-based access control, RBAC, and other security mechanisms to make sure that users and workloads can get access to the resources they need, while keeping workloads and the cluster itself secure. Yes, this is something I will need to work on. Not really because, as I said, it will be my personal cluster where I do everything on the technical side. Maybe a couple of people will access some services. Maybe. Either directly or indirectly, we will see. So not that many role-based access control rules needs to be put in place. I guess, I'm not sure. We will see that too, but it's something that I need to learn more about. You can set limits on the resources that users and workloads can access by managing policies and container resources. That's another nice thing. Before building a Kubernetes production environment on your own, consider handing off some or all the job to turnkey cloud solutions, providers, or other Kubernetes partners. No thank you. I'm here to learn. If they do the stuff, how do I learn? Options include serverless, managed control plane, managed worker nodes, integration. And I will not read even in depth because I don't care about that. Production cluster setup. Now we're talking about the things that are important. In a production quality Kubernetes cluster, the control plane manages the cluster from services that can be spread across multiple computers in different ways. Each worker node, however, represents a single entity that is configured to run Kubernetes pods. So far so good. I will have 3 control planes and 2 worker nodes. For the time being, in the future it will be most likely much different. We'll have way more, well, not really way more, but more worker nodes. Production control plane. The simplest Kubernetes cluster has the entire control plane and worker node services running on the same machines. Yeah, no. You can grow that environment by adding worker nodes as reflected in the diagram illustrated in Kubernetes components. This one. Okay. Kubernetes create proxy, API, scheduler, etcd, CCM, cloud control manager. Yeah, this one is cloud provider API. Yeah, I don't have this too, I guess. And indeed it's optional, so it's not much of an issue. CM, control manager, definitely. If the cluster is meant to be available for a short period of time, or can be discarded if something goes seriously wrong, this might meet your needs. Nope. If you need a more permanent, highly available cluster, however, you should consider ways of extending the control plane. By design, one machine control plane services running on a single machine are not highly available. Yeah. If keeping the cluster up and running and ensuring that it can be repaired if something goes wrong is important, consider these steps. Choose deployment tools. You can deploy a control plane using tools such as Kube ADM, Kops, and Kube Spray. Kube Spray, okay. See, installing Kubernetes with deployment tools to learn tips for production quality deployments using each of those deployment methods. Different container runtimes are available to use with your deployments. Yeah, I'm used to containerd, but I'm open to read more. I tried to use Kube ADM in the past, so I may use that. There are many methods and tools for setting up your own production Kubernetes cluster. Kube ADM, automatic cluster provision tool for tutorials, best practices, configuration options, and information on reaching out to the community. Please check COPS websites for detailed Kube Spray compilation of Ansible playbooks, eventually, provision tools, and domain knowledge for generic OS Kubernetes cluster configuration management tasks. Interesting. Let's open Cluster API, a Kubernetes sub-project focused on providing declarative APIs and tooling to simplify provisioning, upgrading, and operating multiple Kubernetes clusters. I won't be needing multiple Kubernetes clusters, not right now at least, so I will be opening these three currently. COPS, Kubernetes operations. Deploy a production-ready Kubernetes cluster with Kube Spray. Okay, but background. Interesting. We have to think of it as kubectl for clusters. Okay. Okay. I want to be using this one, I think. Maybe it's more difficult to go Kube ADM, but I need to learn things, and I'm not sure this is effective to learn things properly, to be completely honest. So not for that, and not for this. This I don't need it. That's good. Manage certificates. Secure communication between control plane services are implemented using certificates. Certificates are automatically generated during deployment, or you can generate them using your own certificate authority. See PKI certificates and requirements for details. But I think no, I don't see much about that. Configure load balancer for API server. Configure a load balancer to distribute external API requests to the API server service. Instances running on different nodes. External load balancer for details. Yeah, this I think I will need it given that I have 3 control planes. Oh. Anyways, Kubernetes requires PKI certificates for authentication over TLS. If you install Kubernetes with Kube ADM, the certificates that your cluster requires are automatically generated. You can also generate your own certificates, for example, to keep your private keys more secure by not storing them on the API server. This page explains the certificates that your cluster requires. So for the time being, I will let Kube ADM handle this part. The load balancer is something that I might need. Separate and backup etcd service. The etcd services can either run on the same machines as other control plane services or run on separate machines for extra security and availability. Because etcd stores cluster configuration data, backing up the etcd database should be done regularly to ensure that you can repair that database if needed. See the etcd FAQ for details on configuring and using etcd. See operating etcd clusters for Kubernetes and set up high availability etcd cluster with Kube ADM for details. So this is something that I will not care about that much. What I mean is I will definitely back up the etcd database. That is for sure. I need to understand how exactly, but it's not needed now. I will not have a dedicated node for etcd. Sorry. The nodes with the control planes will house also etcd. Create multiple control plane systems. For availability, the control plane should not be limited to a single machine. If the control plane services are run by an init service, such as systemd, each service should run on at least 3 machines. However, running control plane services as pods in Kubernetes ensures that the replicated number of services that you request will always be available. The scheduler should be fault tolerant, but not highly available. Some deployment tools set up Raft consensus algorithm to do the redirection of Kubernetes services. If the primary goes away, another service elects itself and takes over. Okay. This is something that I want to do actually. Multiple control planes is the plan. Span multiple zones. Yeah, this won't be happening. Not anytime soon. Maybe if I become rich one day. Want popularity? No, I don't. And manage ongoing features. If you plan to keep your cluster over time, there are tasks you need to do to maintain its health and security. For example, if you install with Kube ADM, there are instructions to help you with the certificate management and upgrading Kube ADM clusters. See Administer a cluster for a longer list of Kubernetes administrative tasks. That is something that I will need to look into, given I do plan on using Kube ADM. To learn about available options when you run control plane services, see Kube API server, Kube control manager, and Kube scheduler. Component pages. For highly available control plane set examples, see options for highly available topology. Creating highly available cluster with Kube ADM, this is interesting, and operating etcd clusters for Kubernetes. This is something that I will need. This is something that I may take a look. Production worker nodes. Production quality workloads need to be resilient, and anything that rely on needs to be resilient, such as core DNS. Whether you manage your own control plane or have a cloud provider, do it for you. You still need to consider how you want to manage your worker nodes, also referred to simply as nodes. Okay, configure nodes. Nodes can be physical or virtual machines. If you want to create and manage your own nodes, you can install a supported operating system and add and run the appropriate node services. Consider the demand of your workload when you set up nodes by having appropriate memory, CPU, and disk speed and storage capacity available. Whether generic computer systems will do, or you have workloads that need GPU processors, Windows nodes, or VM isolation. Validate nodes. Valid node setup. Yeah, no, I don't want vertical tabs, sorry. Yeah, I will check that page, whatever it is. Add nodes to the cluster. If you're managing your own cluster, you can add nodes by setting up your own machines and either adding them manually or having them register themselves to the cluster's API server. This is something that I may need in the future, but not now. I have a plan for expanding the capacity of your clusters will eventually need. I don't have a plan to have a large cluster. How to scale nodes? Not really. Setup node health checks. Yep. This will be something that I will need to look into. Production user management. This is later. Set limits on workload resources. Demands for production workloads can cause pressure. Both inside and outside of the Kubernetes control plane. Consider these items when setting up for the needs of your cluster workloads. Set namespace limits, prepare for DNS demands, create additional service accounts. Interesting? Mainly the first one is really interesting to me. We will see. We will see. But anyways, this is the plan first, right? Before we begin. Yeah, this is something that I need to check. 2 gigabytes or more of RAM per machine, 2 CPU or more for control plane machines. Full network connectivity to all machines in the cluster, unique host name, MAC address, and product UUID for every node. Certain ports are open on your machines. Okay. So first things first. Let's connect to the various VMs. SSH, not 10, I think it was 101, core, perfect. One or two, and 103. So in here we have the various control planes. Rename -r. Oh, don't turn. You're telling me that oh, it would be really bad if Kubernetes, or better Kube ADM, is not present in here. I don't even remember the command restore things, so I better go in here and anything in here will be this one, RPM OS3, RPM OS3. Yeah, I know. And I wanted to search for Kube APM. It's there, so I don't have an issue. Okay. And if I recall correctly, I don't remember if I have this command in here. Yes, I do. To CPU. Perfect. And -h. I have more than enough RAM. Actually, in the future I may reduce the quantity of RAM used for the control plane nodes. We will see based on the needs. And this is the first thing I need to do, because this page explains two different approaches to setting up a highly available Kubernetes cluster using Kube ADM with stacked control plane nodes. This approach requires less infrastructure. The etcd members and control plane nodes are co-located, and that's my plan. And the other, which has an external etcd cluster. Before proceeding, you should carefully consider which approach best meets the needs of your applications and environment. Option 4, high available topology, outlines the advantages and disadvantages of each. If you encounter issues setting up the HA cluster, please report these in the Kube ADM issue tracker. Okay, so this one, stacked, that's the plan. Let me see. etcd, scheduler, control manager, API, load balancer, worker nodes. Yeah, this load balancer, I don't know where to put it, but we will see. A stacked HA cluster is a topology where the distributed data storage cluster provided by etcd is stacked on top of the cluster formed by the nodes managed by Kube ADM that run control plane components. Each control plane node runs an instance of the Kube API server, Kube scheduler, and Kube controller manager. The Kube API server is exposed to worker nodes using a load balancer. Each control plane node creates a local etcd member, and this etcd member communicates with only with the Kube API server of this node. The same applies to the local Kube control manager and Kube scheduler instances. This topology couples the control planes and etcd members on the same nodes. It is simpler to set up a cluster with external etcd nodes and simpler to manage for replication. However, stacked clusters run the risks of failed coupling. If one node goes down, both an etcd member and a control plane instance are lost, and redundancy is compromised. You can mitigate the risks by adding more control plane nodes. You should therefore run a minimum of 3 stacked control plane nodes for an HA cluster. This is the default topology in Kube ADM. Okay. Maybe having an external etcd host would be better, but I still need 3, it seems. Yeah, even if this goes down, this stays up, or the opposite. But if they exclusively talk with each other, and I don't have a centralized etcd host that talks with all control planes, doesn't make too much sense to have it external like this. So let's go for stacked for the time being. This is alright. Backing up TCD cluster is something that I will look into another moment. Oh yeah, 35 as well, I guess. Yeah, I will use this one basically. But anyways, before you begin, the prerequisites depend on which topology you have selected for your cluster. Control plane. You need 3 or more machines that meet Kube ADM minimum requirements for control plane nodes. Having a node including container already set up and working. Oh, yeah, okay. 3 or more. Yeah, I have two, so fuck it, I guess. In case I will create another one, but not right now. Full network connectivity between all machines, cluster, super user privileges. SSH access from one device, Kube, ADM, and Kubernetes already installed on all machines. Perfect. So, first of all, that means that I also need to go inside the 111, I think, and the 112. Yeah, in the future I may actually use the netbuild installation script, shell script, bash script, if I recall correctly, for the installation of kubeadm and kubelet directory, I guess, instead of doing it manually, but this time I do it manually. And docker, no, container runtime, I guess. Mm-hmm. Okay. I don't know if I can share this, but okay, that is, I think, okay, this is interesting because, okay, that's why. Not sure it's great, but who cares? And let me do this. If I do it in here, they are different, so it's good enough. It seems that everything is different. Okay, check network adapters. If you have more than one network adapter, yeah. Required ports. Okay, required ports. And you were saying, you were saying that I could use NC. I don't have NC. I do have SS. Netcat. And OS3 search and see. Oh, if I search for NC, I want to see if there is something named just NC. No. Nope. But as I said, I had SS. So let me see. I have no idea. Minus ZV minus W what they do. And see, I do it. So that I don't care. Let me take this and let's try to run it on my own machine. Okay, Z0 V verbose. What? Okay, W. Wait. Okay, so I guess I have host name and port. Okay, SS minus help. Instead, how does it work? This is my, let's see, no actually. Okay. What? Terminal mode data types. What? I don't think that is what I search. Activity to investigate sockets. Sockets, not ports. Network exploration tool, scan type. So I do everything. Nope. SS, but I'm searching for other netcat alternative. helmet. Okay, and cat, I don't have it. Happy and string search for a map. A map and cat. And then a map. So I have quite a few things to install, basically. Need to be open in order for Kubernetes components to communicate with each other. So you can use tools like netcat to check if a pod is open, for example. The pod network plugin you use may also require certain pods. Swap configuration. Yeah, I don't have any swap, so it shouldn't be an issue. Installing a container runtime. Okay, I will use containerd most likely. And installing Kube, ADM, Kubernetes, and kubectl. So I need nmap and cat, and then I can check the pods, right? So npm s3 install nmap and cat. Thank you. And while that is installed, I will write a couple of notes. Looking into the documentation of Kubernetes. There are various ways to deploy a Kubernetes cluster. Oh, come on. Thank you. Maybe this is already ready. Should very good. May take a while. Yeah. I have decided to use ADM as I am already acquainted width the container runtime I will be using is container and the etcd database will be structured on the control plane nodes for now. I may look into the possibility of centralized cluster in the future, maybe? The hair in my nose are annoying. And now if I go and cut, it works. Connection refused. Connection refused. I never used land cut, so maybe this could help. I will probably be quicker if I do this, I guess. Map to 168 111 USB 6443, I think. Closed. That means I need to open it. How do I open it? Fedora Core OS open ports. Enable firewall and open ports from ignition. How? This will be interesting because I will be able to actually clean up the configuration. So I need to work on firewall D. Let's check. System CTL status firewall D. I don't even have it. Ports. Ports, ports, ports. Ports. Interesting. Oh, wait. Ports. What are ports? Opening ports. Yeah, but this is what Fedora. Not really Fedora Core OS. Fedora Core OS documentation. Thank you. In this section. Paths. Connection chiave. Host network configuration. This one. Network configuration. Yeah, I went through this page already. Yeah, that's not the case in my case. So, what was it? IP tables. Yeah. Switch. So this is the row list. Okay, so there are no rules. So maybe I can manage everything with this. Oh. Sorry, I'm quite tired already. I don't know. It has been quite a while, actually. Yeah. So. Wow. I think I can use this kind of rule. If I check IP table, minus helper. Append a chain. Insert a chain. Minus P is the protocol. Match multiport. Okay. Deports. Okay. Minus J accent. Minus J accent. Okay. So I can just add these rules. They are all TCP for the control plane, and they're all inbound. So they're all input. Some are multiport, others aren't. So I guess match multiport and deports. And then tables. Nothing here. That's here. Tables. Thank you. Different version. Yeah. Fuck that. NF tables. RPM plus 3. Let's try to use Google manual. Part. Yeah, to be clear, this deport comes from here. And it is a little bit of years old. So even though it may be interesting, I will actually care more about this. And search for port. Port. Parts. Fragments. This means the rule are referred to second effort. Okay. So far so good. Minus A, and so definitely an input. That's correct. Yeah, let's try to avoid being loud. Minus P, TCP is correct. Minus match. Just check the button. Oh. Minus match specifies a match to use. That is an extension module that tests for a specific property. The sets of matches make up the condition under which a target is invoked. Matches are evaluated first to last, as specified on the command line, and work in short-circuit fashion, i.e. if one extension yields false, evaluation will stop. And this is match. Extensions, and here I guess I will find multi-port. This module matches a set of source or destination ports up to 15 ports. Yeah. So match multi-port minus D ports. There it is. So it's correct. Match multi-port minus D ports. And in my case I need 2379 2380 minus J, accept. So what you're telling me is that if I go like this, 2, 3, 7, 8, 6, 7, then 9, and 3, 0. Perfect. If I do this, sudo, and I try again, still closed. It is still closed. I told it to open it. Okay, and chain forward, chain output, chain input. do we need to reboot maybe? We got here the implementation, three line nodes and three working nodes. After the requirements are sufficient, I will need to the optimization in the linear figure. What else? Map and map haircut. Yeah. Huh. It wasn't persistent. So the reboot. Let's try to see if there is a way to have persistent thing. Persistent ipt passwords. So save. You're telling me for Ubuntu, but I have Fedora for OS. Nice. Tables rules require reboot to be applied. No, it took effect immediately upon executions. So it seems that there is an issue. I try to configure the following. part was not open. There may be some configuration missing to open federal kernels open parts. To manage exposure. Yeah, so I will need to do I may need to work on the ports via ignition file, which is totally fair. Across documentation and provisional machines, system configuration between storage and network configuration. Oh Jesus, my eyes are fatigued. My eyes are fatigued. Oh, I'm fairly tired. Are you seriously telling me? Tutorials. Oh. I mean, if I don't open the ports, I won't be able to actually do the rest. So I'm at an impasse, it seems to me. I could install firewall T, but I prefer to configure the ports opening for the ignition file, but I don't see anything about that. you have SE Linux. SE status, I think it's SE status enabled. Okay. Targeted current modem version model. Maybe this is the issue. Maybe, I don't know. Does Linux block ports? Yes. Okay, so do we have something about Linux in Kubernetes? Okay, Kubernetes comes changing policy implements and this Linux modules is supported on Fedora, however do not include SE manage, and there is, we don't know, okay, and there is no sugar in butane or direct support in ignition for Windows operations. See Fedora tracker 701 for more details. Policy disabling. Okay, so I need to manage SE Linux to make sure that I have the necessary ports open. After that, we'll be able to start working on the installation of Kube ADM and such. Okay. Okay. So let me write a note. My default SES come with SE Linux enabled and blocking ports. Anyway, I need to configure to allow ports for Kubernetes. And then we will be ready to install the tools to create a cluster. Okay. I want to say that so far so good. I will end the stream earlier than usual, but it is actually Friday night and I'm tired. And I don't want to say that everything went well, because I wanted to be further ahead than I am now, but as usual we understood things, we know the next steps. So all is good so far. Anyways, thank you all for watching. See you next week, the usual Tuesday streams, and have a great weekend. Look out. Bye.